Welcome, guys, for this session with me, Sarthik Pant. Before starting this session, I'm happy to announce that the registration for BitBox 2.0 has already been begun. So don't forget to register for it. So today, our guest speaker, Mr. Avisek Lahiri, is there. He will be sharing his experience and expertise in machine learning and AI. And he has done his master's and PhD from IIT Kharagpur. And he is working in everyone's dream job companies, and that is Google. Welcome, sir. How is your experience and how are you?
Yes, good evening, Sarthak. Great to be here. And yeah, going on fine. I mean, the situation is not that great. I'm still locked out here in India, trying to see when to move to the US. But yeah, getting some time with the family and the positive side of that. Yeah,
Yeah. Okay. So let us start with the session.
sure, sure.
So the question is, what is your first experience with machine learning and deep learning?
First experience, right? I mean, it was way like when we started, like when I started my master's, I would say. So my master's, though it was from electronics domain, uh, but I was working on video compression and video reconstruction using ML techniques. So previously, like this back in 2014 or 15, when still, like if you all will learn multimedia stuff. So still, the concept was traditional way of predicting motion vectors and then using those motion vectors to do video reconstruction. But at that point of time, ML, especially deep learning, was picking up. So everyone started talking about machine learning stuffs. So my professor then, he kind of introduced me that, okay, you can try to do data-driven approaches instead of traditional approaches. And I think one of the first things which I tried was building my own face detector. I mean, there was already OpenCV detectors, but that was the first time I tried really manually cropping out faces and non-face patches. Like I remember sitting down in lab for hours just to build one simple supervised algorithm to create face and non-face detector. So yeah, that's when I think I first started. And it's kind of, that was also one of the time when Coursera was picking up and when this course was starting. So all of those like tied together. So yeah, that's my first experience really,
Oh,
my
okay.
first step into the machine.
That's wonderful. So, how many other tech stack you explored when you are in college, and what made you choose ML?
Yeah, like to be honest, even when I was in undergrad, so I was always kind of inclined in research. For my undergrad thesis was also on photonic crystals. So those of you from electronics were used to have that concept of stop band and pass band in semiconductors. So those also happen in crystals known as photonic crystals, in which you can pass light. So, so we were doing a physics modeling. So for doing physics modeling at those days, I think I remember using MATLAB as a scripting language for the first time. A little bit of C++, but I really didn't go much into full stack dev in that respect because, yeah, as you can understand, we just needed computational libraries and physics modeling. And then when I came to the research, I came to join masters here also. Um, Most of the work was still being done in MATLAB and C++, because very soon I shifted again to research development. So I wouldn't say I explored a lot in different uh, sta- technical stacks, but yeah, when you're undergrad, you do explore a lot of stuff. Like I remember doing my front end, back end courses. Uh, like databases and some projects small here and there. So I did get a glance of all of those technologies, especially in the undergrads, because that's the time when you explore everything under the hood. And yeah, then what made me choose ML is like I was fantasized that, okay, we'll do all this traditional feature engineering, like, yeah, very nice stuffs. Like I did all this image processing and computer vision courses, and I could understand the gravity of the models and the technologies when people were handcrafting their features. But yeah, here comes deep learning, where you don't have to really uh, hand engineer. Instead, you have to engineer learning models, and that looked quite intuitive to me, and that looked like the future, what people would eventually want to do. You can't always sit down to design features in every new domain that you want to try. So maybe if
Yeah.
you can learn from data, I mean, that's awesome. And 2013 and 14 was the time when everything was quite picking up. And I think that was the onset which made me motivated. And then one of my papers came out, and I don't think I really looked back after that, at not to work in ML. Yeah.
Yeah. Okay. So, but a piece of advice for students who want to find what tech stack they are really interested in.
Hmm. Yeah. So this is, I understand it's very tough for the young minds, especially when you're in undergrad, you've got your courseworks going on, assignments going on. So, what I usually would recommend with my experience now is that it's hard to explore all technologies from scratch by yourself, right? So maybe so that's one good thing in college, right? You get a chance to talk with your peers, with your seniors. Maybe like you got a good friendship with a senior who is doing some .NET project or internships. Just go and hang out with the senior, and just to see what the kind of work what the senior was doing, and what are some of the cool aspects of the project. Because when you start from scratch, nothing seems cool, right? Like you have to build
Yeah.
everything.
Correct.
But if you see someone who has done it for last 1.5 years, 2 years, and this show you some cool demos of what is possible through that tech stack, then you might show a little bit of inclination. Okay, this looks nice. So I mean that is also one of the ways I chose my bachelor's thesis. Like I went to the professor, 2 or 3 professors, and the photonic crystal stood out because he showed me that how we can modulate the impurities in semiconductor to allow lights to pass at certain frequencies. I mean, that just catch my attention. Okay, I said, okay, I don't want to do this. I want to do this. And similarly, we talk about various technologies like front end. Like so, somebody who doesn't know front end, he sits down with or W3 schools and all, and everything looks okay. This is a huge thing to do. But if you just sit with one or two of your seniors, or maybe some peers who have done, okay, can you show me what's going on? What some of the cool things in this stack area? Then you can build a inclination. Okay, this looks nice, and then pick one or two of those and start exploring. Else, there's a high chance to get lost in this ocean of so many technologies
Yeah.
today. Yeah.
Yeah. That's correct. So, what is your current role and what are you currently working on?
Hmm. Okay. So I'm a research software engineer at Google Research. So what it basically means is I'm still a software engineer, but majorly our task is to come up with new models and algorithms. So specifically, I'm in a team which tries to create synthetic talking faces and avatars and cartoons from audio. So you can give it an audio stream, and then you can animate any cartoon characters or face emojis based on the audio. The lip sync matches the audio, and then you can control a lot of emotion. So it's kind of a synthetic uh, pipeline for creating photorealistic faces, or not photorealistic, I would say, high graphics cartoons. Um, so that's the research area which we are currently working on. Like we also published last year, so it's available for demo for everyone to see.
Yeah.
It's called Lip Sync 3D. So we try to not reconstruct. We try to synthesize. Let's say we're doing this video conversation, right? So and we turn off the camera and we just feed the audio stream, but we have one or two reference images of yours, so you can regenerate lively talking face from just that audio. That's just one of the applications that is enabled, which shows promise. So you can save a lot of bandwidth. Yeah, so that's my research area. And yeah, a typical work day in my role is like maybe 70-80% of the time, maybe let's say 50% of the time, we have to read up new papers, discuss new ideas, and then very fast prototyping of ideas, because we experiment with tens and twenties of new ideas, and maybe one or two just clicks out. So rapid prototyping of new ideas, that's one of the major thrust areas of my work. And then when you finalize one or two models, looks good, then it goes to productionization. I mean, that's a separate beast, but that's one small part of my job. Yeah.
Yeah, that's very, very interesting, especially that the Khan thing that you told us. Yeah.
Uh,
So, how should you start studying like machine learning? Is there like theory-based project or hackathons like this?
yeah, that's nice, guys. I would say so. If you want to start learning ML, yeah, it's very easy to be like driven to the fact that okay, let me just download some GitHub repos and just start playing around with that, or maybe just use some scikit-learn libraries and start playing around. But I would usually not recommend doing that. I mean, that's fine for a little bit of hobby building or time pass. But yeah, ML is large, so we have to acknowledge the fact. And also, again, as beginners, it looks a vast ocean. So a strategy which made me feel very comfortable, and I think that's a good thing, is like we still have this Andranges course, right? So it gives you a very bird's eye view of what's the most important techniques that you should be knowing in when you're starting ML. Obviously, it's a very beginner's course. You just can't end your horizon there, but it also teaches you in a very friendly manner, and everything seems doable. So that's a very good starting point. So I would say like anyone who wish to study ML, I think it's becoming kind of compulsory nowadays. It's becoming a tool, not just knowledge. So yeah, so start off with Andranges course. It's lightweight, it's easy to understand, and the best part, it comes with assignments, right? And that's very
Yeah.
important part of the course, which I really found it really interesting, because it's very easy to sit in front of online videos and just consume the content without actually realizing whether you understood or not. But the course usually comes with assignments, so you have to
Yeah.
code up from scratch, and that's very, very important. So the one very good way of learning or starting ML is don't just dive into really cool projects, but try to implement two or three ideas, textbook ideas maybe, but from scratch on your own. I mean, for first 2 or 3 months, it might look boring. I'm not doing anything really awesome, but it really helps you get the confidence to build 10 more complex models, because the complex models are not textbookish models, right? You have to go and change a lot of things internally into the core algorithm. So if you know how to develop the algorithm from scratch, it's very easy. And then you can shine and prosper, and not just uh, cook up a lot of black boxes. And you might come up with a lot of cool projects, but won't take you much further. So yeah, I think you can start off in that way. And
Okay.
yeah, hackathons, yeah, sure. So once you get a little bit of feel of what you're doing, the one thing which is good about hackathon is okay, it makes you know a lot of stuffs in 72 hours or 96 hours. So one bad thing is that you don't know what you are patching up. Okay, this model is not working. Okay, let me patch up one more layer of neural net. Okay, let me patch up one more layer of decision tree, because you somehow have a baseline and you have to beat. So it's kind of not like a learning. I would say it's more like exploring opportunity in hackathons. And yeah, that gives a significant, if you do well in hackathon, that gives a good indication that you can perform under pressure. So those are like aspects which might make your CV good or catchy. But yeah, I really don't feel that hackathons gives you the chance to learn. It just gives you a chance to explore. And yeah, then after the hackathon is over, you might have patched up a lot of things. Then you can go back and study. And make sure to study what you did, because you are in the interviews, when they come up, they will surely go into the details that why did you patch this extra layer. Yeah.
Yeah. Correct. Okay. So, what are some new technologies, like interesting technologies in ML?
Technologies in the sense like sorry, or how would we interpret this, like what do you mean by
Like,
technologies in
what are the
ML?
new projects like that DeepMind or Google is trying to build? in future, so that they can like
Mhm.
yeah.
So nowadays ML, right? Yeah. So ML has kind of become very much integrated with like computer vision and NLP. I mean, I really don't like saying that, okay, ML is computer vision, but yeah, a lot of stuffs are learning based nowadays. And then there is a huge push now like, towards all this story of metaverses coming up. And it's not just a story. If you open LinkedIn, you would see companies like Apple, Facebook, Google, all recruiting computer vision engineers, research scientists. So that requires a lot of ML stuffs. Obviously, this underlying is learning theory, right? And then there's image processing and computer vision. So some of the interesting things which is happening in this space is 3D computer vision, like you want to map your 3D world and learn from. So initially, it used to be just 2D images, right, a matrix of pixels.
Yeah.
Now it's like a volume of points, like you have depth measurements. So what you can do with this volume of points and the depths that you know, what kind of ML technologies can you use to reconstruct your surroundings? Because like let's say when you are navigating in metaverse, right, you have to keep on reconstructing the scene, right, as the observer is moving. So it requires a lot of 3D computer vision, a lot of ML stuffs there. So that's one of the, I think, the very hot booming areas right now if anyone is looking to explore new things. So it's computer vision, ML, and there's a lot of also developments in, let's say, NLP, right? After the BERT model, like a lot of crazy things are happening. And NLP not just really means like summarizing images or paragraphs. NLP has a lot of applications like in genomics. Those are like series of strings, and you need to make sense of that. So I would say like NLP is still, I mean, it's traditional, but new sectors are coming up which are appreciating its benefit and just from the core, let's say, Twitter analysis sentiment or all those projects that we used to think. For example, like we can talk later on. So AlphaFold uses it has got one component of NLP because it's like a sequence of proteins. It's a sequence of alphabets, and then you have those rearranging of those alphabets. So those are very nice domains which you can look at. And if you're just talking about technologies, so you see a lot of buzzwords with reinforcement learning. So I don't see it as new because there's nothing new happening. That the concepts of the control theory concepts of the 90s and the late 80s, it's just they are being formulated in a deep learning setting. So things are looking as if like new. So, but yeah, reinforcement learning is also a major thrust area which is going to survive for next few years to come. So if anybody is starting to, let's say, I want to devote my time towards this, then reinforcement learning should be at one of your priority lists. It's going to take you downstream a lot. It's being used in a lot of places, reinforcement learning, right from product recommendations, online abuse management, then graph managing massive graphs, discovering drugs, new materials. So everywhere where you don't know a concrete loss function and you just want the model to learn, RL is playing a major role there. So yeah, it's a new in that respect
Yeah.
that is finding application in products now.
Yeah. Okay. So, is it important to be well versed with every machine learning domain like CV, NLP, or RL?
Mhm. Uh, it's not necessary, I would say. I mean, at very young stage of career, it's very difficult, right, to be expert in all
Yeah.
of those. You don't get so much time because we do, let's say, bachelors on electronics or computer science. We don't do bachelors on artificial intelligence. So there's a lot of other things to cope up. But I would say at least we can try to do the, let's say, 101 courses for each of those domains. Uh, just one suggestion is, let's say, like we always try to do like repeat courses, right? Just for
Yeah.
the, let's say we have taken advanced algorithm in one semester and 2 semesters after we just take so similar courses but with a different name. This is just to reduce our load. I mean, instead of doing that, we can try to like take this, let's say your department is offering reinforcement learning course, or let's say convex optimization course. So, so at least what I say, like the one-on-one courses, if you have a good coverage, it should give you a good foothold to start off with. And it's impossible, at least at undergrad level, even at masters, to go deep into each of those, because those are more or less this try. You will not use all technologies in one paper in or one project, and then a good project takes up 1 year or 1.5 years of your time. So that's not possible. But yeah, try to get as many courses done in your curriculum. And then when you apply for jobs or research internships, you have a good foundation. It will be easy to build up on top of that.
Okay.
Yeah, so don't stress about learning everything in much details.
Yeah. Okay. So, what's your take on how the demand of machine learning engineers will be changing in upcoming years?
Hmm. Oh, ML engineers, I think it's quite high now. The demand is pretty high. In fact, though on the contrary, I just shared an article a few days back on LinkedIn, where the IEEE Spectrum article, which shows that the average salary of ML engineers in the US is going down a bit. It's mainly because now people have started realizing the importance of ML. So everybody is studying ML, right? So it's not just this dearth of ML engineers. Well, 4 or 5 years back, not everybody was studying ML. Now everybody is studying ML.
Yeah.
So there's a little bit of decline into this overall salary, if you look per se, but that should not demotivate us, because only every new day and people are realizing the potential of uh, automated reasoning and ML. So if you just forget like ML from a computer vision or just NLP point of view, which is quite competitive and kind of it's everyone's stream. Like if you say, okay, ML, what do you want to do? I want to do computer vision. ML, what do you want to do? I want to do natural language processing. But there are other sectors coming up, like let's say weather forecasting. The Google Research has a team in Netherlands which does weather forecasting. Then ML is being highly used in smart agriculture. Like there are a lot of startups coming up in agriculture domain. Then you should try to look at bioinformatics domain, where they're doing ML for doing drug discovery, right? Because all of these are exploration problems. Then even just yesterday, a DeepMind's paper came up where they're balancing the plasma levels, where their reinforcement learning shows how to balance plasma level in nuclear reactor fission. So even basic science companies are hiring ML engineers, research scientists to do this data-driven learning. So at some point of time, you might find like computer vision and NLP companies are kind of getting saturated. They're very tough to crack. But there are these other sectors, the whole new sectors, the fintech sector. It is like booming, right? They have massive amount of data, and their work is to predict. Data prediction might go wrong, like what happened in case of Zillow. So sometimes happens, but they're still betting big on predictive modeling. So yeah. So for coming few years, ML demand for ML engineers is going to stay, and it's just going to rise from this point onwards. So good days for us. Yeah.
Yeah.
Yeah, just as
Okay.
a takeaway, I also shared a few days back. If you are a young mind in undergrads, it's good that you concentrate on ML, but there's also this entire spectrum of blockchain and Web 3.0 coming up. So apart from ML, if you can also explore that domain, like that's going to take up big in this coming decade.
Yeah.
So apart from ML, that's also one of the areas like blockchain development, blockchain technologies. That will also have ML stuffs, no doubt in that.
Yeah.
But we're learning the core blockchain technologies might be also good, because that will be the next tech area where there will be shortage of talent, and so much bigger demand will be there. Yeah.
Yeah. Correct. So, how to be self-sufficient and have confidence in what you are currently doing
What do you say? Oh, you mean from my personal aspect, or like you're talking in terms of
yeah,
like?
in your
Oh,
personal
okay,
aspect?
okay.
Yeah.
Oh, okay. Yeah, I would say it's tough, really. Like you've heard the word imposter syndrome. So when you're in the big tech companies, you tend to get a little bit imposter syndrome. That's quite because I'm always surrounded by uh, very cool research scientist, very knowledgeable person. But yeah, the good thing is that at Google, like most of my managers and peers are super helpful. So initially you might feel, okay, they are super geeky, what am I doing here? But they are very helpful in that respect. So it eases out, even though like it's been around, so I've spent around, let's say, total 2 years as an intern during my PhD, and now around 1.5 years as full-time. But I still get that little bit of vibe that, okay, I might not be performing because everyone is doing really awesome in the tech, right? So that you will find across all the big companies because you're always surrounded by super smart people. So there's always a tendency to feel that, okay, I might be missing out on the rest. But yeah, what I try to do is like keeping like small goals for myself, right? Research is very open ocean, right? So you might just spend a 1 year doing nothing, just exploring stuff, and then at the end of the 1 year, you have nothing really concrete to show. So, so what I usually try to do, okay, keep a big goal in picture, like a moonshot, which we want to publish, let's say next year, and then there are some low-hanging fruits, which I know will give what kind of results. And those are mainly like software hacks or let's say some systems design and then make it happen. So those are like low-hanging fruits. I work, let's say 20-30% of the time on that because you keep on getting good results, right, on those. And that gives you a confidence, okay, something is happening. The wheels are rotating. And then you have the bigger, the more ambitious projects, which is like as a lead, I have to also pave what's the future of technology or the future of our product would be. And so there's a lot of uncertainties. So, so this is a challenge in research role because you don't have immediate quantifiable outcomes. Because if you know what the outcome was, then probably it wouldn't have been in the research phase after all. So, I mean, that's also applicable for young researchers like you also. You can, when you start doing, let's say, exploring research stuffs, don't just take up a big problem, a very hard problem by yourself because you're already surrounded with so many courseworks. So try to build up on small projects. Maybe a paper has been released, whose code has been released. You just try to reproduce that so that you get a small results, but at least you yourself content. Okay, I'm doing something. Something is happening. If the target is too big, nothing happens in 4 or 5 months, then it's very easy to get distracted. Especially if you're surrounded by great peers and some of their papers get published, you get more, oh, what am I doing? So it's always important to keep small goals also to keep yourself and your inner happiness busy that, okay, I'm getting happy every day with something small happening. Yeah.
Yeah. Okay. So, talking about internship and job, how to get exposure when in search of internship and jobs?
Yeah. Yeah, I can comment on that. It really varies, like at what stage you are. So mostly speaking, all my internships were starting from master's level. So all my intern at Facebook, Google, USC, all were when I was in master's and PhD. But let me just comment also what to do now in, let's say, bachelor's level, like because our audience might be more from the UG background. So what I would suggest, so I'm talking mainly from, let's say, machine learning point of view.
Yeah.
I think it will also hold true for other domains of CS also. So let's say you develop some small project, like you always have clubs in your colleges, like robotics club,
Yeah.
autonomous driving club, front-end development club, like whatever clubs, right? So you do contribute something. So I've always found it very helpful, at least at junior level, if you maintain a good GitHub profile for yourself, like even if it's a small project, maintain a very good write-up in the README so that, let's say I am reviewing your CV, right? So I really don't want to see the CGPAs and all that secondary comes up. But I want to see what the projects you have done. So I click on your GitHub link and immediately it catches my eye. Maybe it's a small, let's say you just have predicted whether an email is spam or not spam, but you write it up nicely, like what are the steps you took, right? And what were the quantifiable outcomes that you got, right? So this is the first starting point, right? And then, so I'm just trying to tell how do you catch the attention, because there are so many internships going on, right? So many applications. So how do you catch the attention of the recruiters? And then maybe, let's say, your professors always give you some coursework assignments, right? Mini projects or something
Yeah.
like that, right? For example, let's say you're taking a image processing class, and then your professor has asked you to, okay, can you remove his? So as I know, when I was taking the image processing class in Kharagpur, there used to be mini projects of 4 or 5 weeks. So we used to have problem statements like, okay, can you remove haze from this photo? Or can
Okay.
you remove glare from this photo? You might use very traditional techniques. Obviously, it's not expected you will do out of the box techniques. And if it is a traditional technique, it's a project, right? So you're writing codes, you're doing something uh, realistic, which will be applicable in real life. So put everything on GitHub with a good write-up and the results and visualization. So what it does is that it immediately catches attention that, okay, this guy, this girl is good at maintaining code, good at presenting, and I can instantly just click on the code and just try to say, okay, the code looks nice, and try to maintain a clean code. I mean, don't put all experimental codes there. Like, it doesn't have to be super fancy, but at least try to keep it clean, because you're just trying to grab attention, right?
Yeah.
So that's a UG level. Obviously, try to link. So that's like from what you can do from an academics point of view. The other one is very important, is networking, right? So you
Yeah.
have got your seniors. So and you know now, right now, like the referral system works works very good in large tech companies. It's not 100% guarantee, but there's a good chance you get interview calls. So that's the first thing, like to get the interview call. That's where most of us stumble. So do try to maintain congenial relation, let's say with 4 or 5 of your seniors, because what happens, maybe they're in third year, no worries. They might have come back and they might still be in contact with their managers, right? And they can say, hey, here's my junior who is doing great. Do you have any vacancy there? That might catch up more attention than you sending to that manager as a fresh person. So these are like life skills hacks, which will tend to give you good outcomes. Like I can say personally from my experience, like all my full-time jobs after PhD, except at Google, I network everything through LinkedIn. Yeah, I have to spend around 1.5 hours of time every day when I was doing the job. But yeah, I did but try to maintain a good network over LinkedIn. And yeah, coming to LinkedIn, that's also very important. Like, let's say you're just bachelors, right? You might think, oh, what have I done so much to create a LinkedIn profile? I don't think like that. Like, at whatever stage you are, try to keep your LinkedIn and your CV updated. So keep your CV already linked, always linked. Because you never know, right? A recruiter might just be scanning around and just hitting on your profile. Like I've got several calls like that from the Salesforce US, Qualcomm Amsterdam. So they were just navigating the profile and they just see, okay, everything looks good, the profile looks
Yeah.
good, and so even there. So now that I'm on the other side of the table, we also know how painful it is to recruit someone. So we are also looking to recruit good people. So, but it's a task up to the candidate to maintain his or her profile really nicely and to be completed. So I think with all those things at undergraduate level, you will get a decent chance of getting internships. And then slowly when you move to undergrads and PhDs, I think that's long term.
Yeah.
Your research speak for yourself. So for example, even at undergrad, right, let's say you read some research paper. What I usually prefer doing is that I directly mail the authors of the paper. Let's say that's how, frankly, I got my internship at Twitter also. So I saw their super resolution paper. So I could have just logged into Twitter's job profile and get, and it's very tough to get calls from there. But I just got in touch with the lead authors of the paper, and they found my profile to be matching. I'm not saying that 100% you will get back reply, but there's a good amount of chance that a human who is reading your email will reply back if there is a match. So try to do that, especially for research interns. And what? And also, there are a lot of research internships opportunities, like let's say Viterbi India, SN Bose, MyTax, then NTU, like the Nanyang Technological Institute, Singapore, EPFL in Switzerland, and then CERN in Geneva. I'm just picking out the names. Maybe you can listen back the recording. So these are some of the areas. These are some of the organizations and companies where, as an undergrad, they take bright students as research. Because I do understand it's very tough for an undergrad to get research internship per se,
Yeah.
because the company thinks, oh, as an undergrad, what research will the candidate do? even if the candidate is good, they always search for MS or PhD because there's a high chance that MS or PhD might do better at research interns. So I understand the difficulty. So this is some of the baselines from where you can start. These are academic research internships, the last 4 or 5 names which I spoke. So
Yeah.
you can explore those. Yeah.
Okay. Yeah. Amazing. So, uh, a student is the higher education something everyone should aim for?
Yeah. Um, That's a tough thing. So let's say you are more into, let's say, let me take it in this way. So I have some of my friends, they were quite brilliant, like they were ICPC World finalists, top 10. Like, so you can understand the kind of maths they do.
Yeah.
And I'm not just saying that they were good coders. I know like they were also Olympiad gold medalists.
Yeah.
So there was no doubt that he was one of the best math guy I knew. But he didn't go on to do higher education because well, he's a pass out from Kharagpur Computer Science,
Yeah.
but most of his peers went to do. But here's the thing which I learned: like he was very good at systems design, like coding up new frameworks, integrating a lot of services, and that's where he finds his passion, right? So, if you are someone who is like more into systems building, exploring new tech areas, I mean software tech areas.
Okay.
So by that what I mean, so this is C++ is, let's say, a procedural language, right? But TensorFlow is like a graph based language. So there's difference of the tech area, the how you code up the logic and how the execution takes. Let's say you are very interested in GPU programming.
Yeah.
So you might be that kind of a person. So for that, you might not need always like a master's or a PhD degree because you're more into developing tech, developing open source, and that's what interests you. But then there maybe then there are candidates like you might say, oh, I have very good interest to work, let's say, on computer vision. I have very good interest to, let's say, work on AI in healthcare, right?
Yeah.
So I should acknowledge getting those kind of specialized jobs immediately after undergrad might be tough. Again, the intuition comes, you might be good at coding, but you might not have the domain knowledge, right? So the domain knowledge is also what the companies would look for. So if you're
Okay.
someone who is more into like, I want to explore new, let's say, now take from an academics point of view,
Okay.
and not take from a software development point of view. So for example, I was talking about this metaverse stuff. So there's this whole new evolution coming called neural radiance field, right? So this is basically like creating new views. So you just give me an object, I like a sum of the views of an object, and this nerve, which is a short form for neural radiance field, creates you
Okay.
new scenes. It's like that almost. It's kind of like how you use the Facebook 3D photo, right? It hovers a
Yeah.
bit here and there. So, but
Okay.
it's much advanced version of that. So
Okay.
if you're just into software engineering, it might not be possible for you because that's whole new computer vision and ML stuff going on, right? And
Yeah.
but there's a whole new stack of code also going on. There's very complex codes going on. So if
Yeah.
you are someone who want to try out that kind of new avenues of new kind of academic texts, then I would suggest that if you don't have, let's say, financial burden at home, and there's no other thing holding you back, then you should most probably at least go for a master's because that kind of specializes, and because you get to choose, right, what kind of domain you want to do masters on. But but let's say, having said that, so nothing is end of road. So there's these opportunities, right? I know many of my friends who, let's say, entered Google and Microsoft after undergrad as software engineers, right?
Okay.
So all of these companies have their own respective research labs. Like Google has Google Research, Microsoft has MSR, Qualcomm has
Yeah.
Qualcomm Research. So what I usually see, like if you're very interested in new academic texts, you engage in 20% projects internally in those companies, right? So all of these good companies have something called 20%, 30%
Okay.
commitment. So you work 20% of your time in a research project with the research people. And
Yeah.
then you start studying that part, and then you internally make a shift to research. So it's not that maybe at the age of 21, you are very interested in building systems, you enter a high-tech company, and then maybe after 4 or 5 years, you think, oh, I want to study new academic stuffs, but I don't want to go into masters. But this is also an opportunity. Like all of these good tech companies also have got a good research vertical also, and you can easily collaborate and then slowly shift. So I know some of my friends who joined us in Google, they shifted to DeepMind or Google Brain. It's just internal shift. So So this is not a binary answer. I think you could get a bigger picture, like the necessity of higher education.
Okay.
Yeah, yeah,
Okay, nice. It's an interesting project that I personally liked. I studied about it. So what are your thoughts about AlphaGo?
yeah. My
Yeah,
thoughts. I think the world has already commented a lot on that.
yeah,
No, it was amazing. Like it's
yeah,
like it was like a fairy tale. When you like, we got the news first, but then when you see also the Netflix documentary, like how they put it up, all the stuff. I mean, it's just amazing. I mean, hats off
yeah,
to David Silver and his team. I mean, we
yeah,
all, David Silver has always been my role model while studying RL. So he's also doing a lot of cool stuff. So AlphaGo now has got into AlphaGo Zero and Alpha Mu.
yeah,
So all the versions after that. So yeah, I mean, nothing really much to add on that. I mean, obviously, mm, it was a path-breaking evidence that a large-scale deep learning and large-scale RL will eventually help us to understand very complex problems. And it was
yeah,
like learning from imitation, right? AlphaGo. So it
yeah,
learned a lot by looking at expert games. So
yeah,
all of these were in concept. Like imitation learning is like a very old concept. Like I said in the beginning of this session, like RL is a very old concept, like the policy
yeah,
learning and the controls. But like taking those old concepts and making this kind of massive system and having such kind of real world impact. I mean, that's what DeepMind is for. I mean, it's
yeah,
an organization who will define that what ground breakthroughs it's possible from an AI company,
yeah,
and that's what they kind of achieved. And then people started believing in their technology. So yeah, I did see like so one of the comments which I found interesting from Lee Sedol's commentary was like how he said at one point of time that playing 5 games in a row, like he was kind of getting stressed out. There's a humanly
yeah,
fatigue part of
yeah,
that aspect, right? So that's what I liked about this. So if you have like a human level capability of a system, and then it gets like devoid of any prejudices of anxiety,
yeah,
tension, environment, and impact. So let's say even if the model is bad, it will perform consistently, right? So the consistency of a model, especially of an AI model, is something that we would want. Humans, we are never consistent, right? Like Sachin might get out in the first over Yorker, and
yeah,
I mean in the first over Yorker he might smash it for 6. But there's a good chance like AlphaGo might be playing around same strategy. So there were a lot of praises even from Kasparov. Like the playing was quite dynamic, mimicking his style.
yeah,
So all those good things were there. So what's good is that the DeepMind didn't stop there. So they went on to take out AlphaGo because it was still based on human imitation, right? So then they went on to go AlphaGo Zero, which they played 2 agents with each other, right? So 2 agents are playing along with each other and they're learning the rules of the game by just winning or losing, and that also did quite remarkably. I think it didn't come out so much in limelight like Lysidol's 5 match gamer because that was the first time. But
yeah,
AlphaGo Zero kind of shows that AI systems have the capability to learn very in an unconstructed environment just from like self-playing. And why is it important? So Dennis always comments, and uh, David Silver also has comments that it's just not based on gaming. Now they're taking the concepts learned for doing other avenues, like they're using the similar exploration. So it's all based on exploration. Like AlphaGo Zero is also based on intelligent tree traversing. So all these explorations are helpful in other really critical domains like drug discovery, which I have spoken. I've used the word a lot of times here. So drug
yeah,
discovery basically means you have got a lot of molecules. You know the molecules. So when you take a tablet, it's like it's just basically a good 3D arrangement of molecules, and that makes up your medicine. But that arrangement of molecules is quite complex. There's a lot of paths to take. So they're already doing that. In fact, that's one of the recent breakthrough in 2016, that AlphaFold, if you might know. That so they actually they cracked one of the very old problems in drug discovery, like even a sequence of amino acids. Can you predict the 3D shapes? So sounds simple. It is because it's just a series of letters, but there are zillion combinations in how they fold up in 3D. And why is it important? Because it's the structure of the amino acids in 3D which really determines how that protein is going to react with your body. So what are they all doing in this COVID tracing? They're trying to understand how the amino acids are arranged in 3D. So that's why it takes up so much amount of time. But AlphaFold, they solved one of the grand challenges. It's now at the top competitor. They're doing it. It has broken the last ceiling, which was run with traditional methods, and already it's having impact because we just study the spike proteins in the news. You just see always, okay, what is the spike protein structures? But there are also other proteins which are important, and AlphaGo has already predicted, AlphaFold has already predicted 5 or 6 of those protein structures. So it's like taking the knowledge, the motivation of AlphaGo, it's having a really good impact. And just recently, just yesterday evening, the hot paper came out where they are stabilizing nuclear reaction plasma level. So I'm not a nuclear physicist, so what I could understand, you need to maintain a plasma level at an accurate level to for an optimum operating of nuclear fission, and with reinforcement learning, they are able to predict that level. So they are now spreading out everywhere. It just needs to be seen whether governments and regulatory bodies believe their system. But this Alpha Star, AlphaGo, AlphaFold, so this Alpha Star family is really showing us promise that what all can be possible. So good days for us.
Yeah. So with that AlphaGo and Alpha Stars community, do you think that AI would be dangerous in the future?
This is a very used, common question. Like people think, especially like after Terminators and Skynets. The usual threat, like even when I was small, I was like 6 or 7 years smaller than current age. I was also used to think, like looking at Boston Dynamics robots, that this is like a replica of Skynet. Right. Those are there, like AI guided warfare, AI guided drones attacks. Those are there, right? So those are regulatory bodies. Somebody won't say that those are not possible to like drone technology has gone to a new level now, right? So it doesn't take much to, if you are a bad person, it doesn't take much to rig up those and do harm, right? Like there's this famous, not famous, there was this dialogue, like if you have seen aspirants, like it was said like the same power which you use to light up bulb, the same power you can also use to kill a human, right? So drone is used to a large extent in agriculture. It's one of the now key elements in smart agriculture because it does targeted spray of pesticides where it detects that there are damage in the farm, where you can just replace pesticides with anything else you want, and then it becomes a bad drone, right? So, but that's like, we think about machines and drones as the future killing us. But as the new generation who like yours, who are starting out, I would want to point out that there are, so this robotic warfare is something which we think of as a fantasy, but there are already intricate worries with AI, which is going to hit our society. And they are not robots. They are, what the biggest threat currently is the biasness, how we are deploying AI. So to all my audience who's listening out, starting their research career, you might want to explore the like biasness in AI as one of the critical threats to our society. Let me just give you some examples about what I mean. So I can't name the company, but it's one of the big tech companies who had to restrict their proprietary hiring software in 2018 because it was shown that it's kind of discriminating against women because it relies heavily on data, right? And data is collected by human. It has historical prejudices. It has historical bias or how we conduct it. So if you're training on data, it's very imperative that the model will copy whatever wrongs that we have done as humans, as civilization. So it's just mimicking it's done. Then there are healthcare issues, right? Like AI in healthcare is picking up, right? So like you get a lot of smart watches, a lot of smart recommendations, but who is going to regulate the security of your information, like the privacy of your information? Like those are very sensitive data, right? Your financial information. A lot of fintech products are coming up. We will recommend this mutual funds, that stocks, this EPS, but they're practically tracking your financial information, right? And then just coming out with this. So it's like so there's a major threat that your medical and financial information is visible to the crowd. And then there are specific examples like the US was at one point of time using AI for lawmaking and targeting and trying to predict which areas having more probability of crimes. And fortunate or not, it comes out that by default, but with a large chunk of confidence, it would predict that where the income is low or where there are a less number of non-white peoples. So because again, it's based on historical data. And
Yeah,
one of the major threat areas nowadays is deepfakes, right?
yeah,
Like if
yeah,
people know
correct.
what deepfakes is, you don't know what the face is realistic or not, and that's a very serious problem
Yeah,
because as a researcher, we might have the bright eyes to catch it, we might have the tools to catch it, but it's being propagated to the public at scale, right? And those
yeah,
are getting freaky awesome with GANs and generative models. So these are like very, very realistic concerns and security aspects. So they don't sound fancy or look fancy like robots fighting with us, but these are actually some real concerns which are there to bother us, and we have to be really be so there's a lot of research is now going on around mitigating bias and fairness in ML. So that's also one of the very research areas where people can look into, and it will have a long impact because the next decade or so we will be shifting from manual intervention to AI guided automatic decision making processes. So it was a whole new area. So I was just looking at some of the Siemens and Tesla's work. So let's say you are driving an autonomous car from any company and it hits a pedestrian. So who is just responsible for that? Is the data science algorithm? Is the driver because he could have taken
yeah,
he or she, or is the manufacturer? I
yeah,
mean, or is the LiDAR company? So because who has taken the final decision? It's still based on historical data. Maybe it was trained that okay, given a human and an animal, okay, just run over the animal. Maybe that's our instincts was. So all these are like very open-ended concerns which are still there, and research is going on. It's good for budding minds that they can concentrate on these parts. And this is a really challenging aspect which society wants to look at. If AI is something which we well, because as soon as it comes out of computer, you have inherent belief. Okay, this is computer; it won't do wrong. But the fundamental aspect is the way it was trained. That data might have been wrong, but you will
yeah,
just forget that part. You will just say, okay, some big tech companies stack is saying that okay, this person is meant to be a criminal or a credit defaulter, or it has to be true. Yeah.
yeah.
So those are very serious issues to look forward to.
Yeah, it's been a great talk, and thank you very much. So now we are open for questions. So Amog, so yeah, Vikrant is asking what is the future of reinforcement learning and why Lee Kun called it a cherry on cake in spite of success in many complex game.
Okay. Yeah, it's tough to comment on what Jan LeCun says. I mean, I think from the point where he's coming from is that, as I said, let's say like a lot of things are happening in RL, right? And people are celebrating, oh, great research is going on. It hurts the traditional people to some extent, I know, because none of these concepts are new. Because they are from the 90s and the 80s. You will see a lot of control people working in RL nowadays. So
Yeah,
it's not something new. So the hype is okay, this is something new coming up. That hurts the sentiment of leading researchers and traditional researchers. So RL was there. I don't know why he calls it cherry on the cake. I think the cake is something like that. The RL was already there, right? So everything was already there. So it's just with deep learning and GPUs that it's now you're making it now more, let's say, fancy, and it's solving like fancy problems. So that's like a cherry, because if you just sit with Burton's RL textbook, you wouldn't find, oh, this is so boring, or what are this guy speaking about, if you study the textbook. But if as soon as you see AlphaGo's video, you say, oh, this is really nice. But the concept, the math behind it is the cake. I mean, it was there for the last 2 or 3 decades. So what's the future? Uh, We touched upon a little bit on this. So first of all, it's being highly used now in, let's say, drug companies to find out new, again, drug discovery. I can keep on forcing because I've got a lot of my computational friends who did like PhD in maths and physics. Now they're shifting to drug companies because they're good in maths, they're good in simulations, and they're good in RL. So they're doing a lot of drug discovery stuffs. And even if you look at retail vendors like, let's say, Amazon, Walmart, so whatever they're doing is like they're trying to predict your behavior based on n number of factors. So let's say today is, let's say, Diwali, and you are in North India, so there's a high chance that you might be ordering, let's say, laddus. Like, I'm not speaking of, this is one of their blogs. So there's a lot of, like, you can't really code those concepts in hand. Like, there are a lot of things at play, and they have to explore a lot of variables before coming to a recommendation solution, right?
Yeah.
So the core thing where it started like bandits, like in RL, there's this concept called bandit learning.
Okay.
It started from the concept that suppose you are in a casino, one lever gives you reward and one lever gives you penalty, and you don't know, you want to maximize the reward. So that's where the story starts from, this bandits, and the sum story of maximizing in reward in big scale now boils down to Netflix, Amazon, Walmart scale. So
Yeah.
I would say that the future is really bright, at least for coming decade in RL.
Yeah. Okay. So, do you have any advice or encouragement words for students?
Okay. I mean, advice. I mean, advice on what front? Sorry.
Advice in like how should they pursue their career, or like in general, not just in MA, in general. Yeah.
Sure. So, yeah. Firstly, like, try to enjoy your undergrad days. I mean, lot of people will come and say, okay, get this GPA, get this internships. I mean, this 4 years of undergrad, that will be the ones you will remember, because once you later go to masters or PhD, you don't get the group of friends or circle that you would remember for the rest of your lives, because people become more matured, they have their own priorities. So this 18 to 22 age is the cream of your life. So try
Yeah.
to first take out some time to enjoy with your friends. So that would be
Okay.
the first suggestion. A lot of ML talks today. And then
Yeah.
and then there's this thing. So I also posted it in LinkedIn a few days back. So don't get too much complacent to get very high GPAs unless you are targeting really good universities for MS. So I would say let's a thumb rule. So if you're getting like 8.5, 8.8-ish stuff, you are good to go. So don't pressurize yourself. If you're doing that and maintaining a good, as a like personal life, a social life, I mean, that's very much important, instead of going for the 9.1s and 9.2s and just finishing up your life.
Yeah.
So, yeah, try to keep it above 8, because nobody will tell you. But in the background, whenever somebody looks at your CV, this is the truth, right? So I'm just telling you honestly, right? So it's always good if you try to maintain it above 8.
Yeah.
And then don't force yourself to get it above 9, because you should
Yeah.
also, yeah, right. So in between, you should enjoy your life. That's 18 to 22 is the time to enjoy, because then you have entire life to struggle. So just try to enjoy. But one thing, if you are really serious, let's say about cats, and let's say about foreign MS and PhDs,
Yeah.
then it's my advice that, yeah, GPA does matter. Then somebody should not mislead you. GPA doesn't matter. It really matters if you're targeting good universities abroad. So your priorities are set, right? So what you want to do, and then when it comes to jobs, again, I acknowledge that you might think, okay, recruiting session is coming. I'll show my parents that I got, let's say, 30 lakhs, 40 lakhs CTC. Something
Yeah.
doesn't work out, right? And
Yeah.
this is a major source of concern for students, that, okay, my friend got X lakhs, I got, let's say, 70% of X lakhs. I mean, so I just taking about email and all this stuff, taking academic stuffs, because this last 2 or 3 minutes is just to
Yeah.
motivate you all. Because I've
Yeah.
seen, like,
Correct.
you see, we see a lot of stuffs in the IITs and also in other campuses, the pressure during the recruitment season. So the job that you get at the age of 21 or 22 doesn't really define what you're going to earn at 30s, right? So
Yeah.
it's very competitive on that day zero or day one to crack that job. But nowadays, like, there's so many opportunities.
Yeah.
So maybe after 2 years you will get the switch, and maybe your friend who got at X lakhs per annum, he doesn't or she doesn't switch, so you will in any case get more than that person because you are switching, doing a lateral shift. So
Yeah.
just I know a lot of people say, but I hope the juniors really take this into account. Like, don't pressurize yourself that at the age of 21 that's the end of your life and you have to prove everything by the time you graduate out.
Yeah.
I mean, that's absolutely wrong. So, for example, like when I graduated out of my college in Kolkata, the Google was a dream for me, right? So at that point of time, I couldn't dream that I could be competing in this large tech sectors. But life gives you a lot of opportunities, and yeah, what I always try to say that stay alert, like whatever opportunities coming up, don't just crumble back. Okay, I have failed one time, I could get a good job. So keep your opportunities alive. Like as soon as you see any new job postings, internships, just apply to it. That don't think that I'm not good enough to apply,
Okay.
because many a times has worked out for me. I've cracked some of the toughest internships, and I personally never failed. I was so good for that. I don't know, luck
Okay.
favored me, but yes, do apply to very good internships and openings when you see
Okay.
them. Instead of spending that 1 hour on Facebook or Netflix, just spend that time on applying to that position. You never know what works out.
Yeah.
Yeah.
Correct. Okay, thank you, sir. It was a wonderful experience hosting this session with you. I'm sure this your expertise and skill advice will help our audience to pursue their goals in this field. So yeah, so to start this ML journey, don't forget to participate in BitBox 2.0. Our registration has been begun. You can also join our Discord and Instagram. That the link has been provided in the description and also in the comment section. Thank you all for joining this session.
Thank you, Sarthak. Bye bye. Have a nice
Yeah.
day.